From the air, Kansai International Airport looks almost unreal. Two enormous runways stretch across the ocean. Terminals, taxiways, roads, control towers, and thousands of passengers sit on what appears to be a perfectly normal piece of land, except none of that land used to exist. Japan built the entire airport on artificial islands in Osaka Bay, roughly 5 kilometers from the coast, because putting a major airport offshore solved two problems at once. It reduced aircraft noise over densely populated neighborhoods and avoided the enormous cost and conflict of buying huge amounts of land around Osaka. But moving the airport into the ocean created a much bigger problem. Before Japan could build the terminals, runways, roads, or even the first gate, engineers had to create the ground beneath them, and almost immediately that new ground began sinking, not by a few centimeters. The first airport island has settled by more than 13 meters since construction began, and even today it continues moving downward by several centimeters every year. The strange part is that engineers knew this would happen. The airport was never designed on the assumption that the island would remain perfectly still. The real challenge was predicting how much it would sink, how quickly it would happen, and whether an airport could continue operating while the ground beneath it slowly compressed. That makes Kansai less like an airport built on solid land and more like one enormous engineering experiment that has been running for decades. To understand why Japan attempted something this extreme, you first have to understand the problem Osaka had on land. By the second half of the 20th century, air travel in the region was growing rapidly. Osaka already had Itami Airport, but expanding it was difficult. The surrounding area was heavily developed, and aircraft noise had become a major issue for nearby communities. A major airport needs far more than a runway. It needs huge clear zones around those runways, taxiways, terminals, cargo areas, maintenance facilities, roads, parking, and space for future expansion. Finding that amount of open land beside one of Japan's largest urban areas was extremely difficult, so planners began looking offshore. If the airport could be placed several kilometers out in Osaka Bay, arriving and departing aircraft could spend more time over water instead of neighborhoods. Land acquisition disputes would largely disappear, and the airport could operate around the clock with fewer noise restrictions. The idea solved the city problem perfectly. It just required building an island large enough to support an international airport. Construction on the first island began in 1987. The site was sitting in water roughly 18 to 20 meters deep, which meant this was not simply a matter of dumping a little sand along the shoreline until new land appeared. Engineers first had to deal with the seabed itself, and this is where Kansai's biggest weakness was hiding. Beneath Osaka Bay were thick layers of marine clay. Near the surface was relatively young alluvial clay containing an extraordinary amount of water. Kansai Airports says roughly 70% of the volume of this upper clay could be water, while some deeper clay layers contained around 40%. That sounds like soil, but mechanically it behaves more like a very slow sponge. Imagine placing a heavy object on top of a thick sponge filled with water. The sponge does not instantly become flat. At first, the water trapped inside supports part of the load. Over time, that water slowly escapes and the sponge becomes thinner. The exact same thing happens with saturated clay. Now imagine placing an entire artificial island on top of it. Hundreds of millions of cubic meters of rock and soil were eventually used to build Kansai's two airport islands. Research on the project puts the combined reclamation material at roughly 430 million cubic meters. Every additional layer increased the pressure on the clay below. Water trapped between microscopic soil particles began being squeezed outward, and as that water left, the clay compressed. The island sank. That process is called consolidation, and engineers knew it would happen long before the first airplane landed. So instead of trying to prevent all settlement, they did something that sounds completely backwards. They deliberately tried to make the seabed sink faster. Before much of the island was constructed, a thick layer of sand was placed across the seafloor. Engineers then drove enormous numbers of vertical sand drains down through the soft upper clay. For the two airport islands combined, more than 2.2 million of these drains were installed. Normally, water trapped deep inside clay has a very long distance to travel before it can escape. That means consolidation can take decades. The sand drains gave the water shortcuts. Instead of moving slowly all the way upward through impermeable clay, the water could travel sideways into one of these vertical sand columns and then move toward drainage layers much more easily. Now, the weight being added above could squeeze water out faster. In other words, engineers were intentionally accelerating the sinking process before the airport was completed. That sounds like destroying your own construction site, but it is actually much safer than the alternative. If the ground is going to compress anyway, you would rather make as much of that movement happen before the terminal, runway, and other structures are finished. It is similar to pressing down hard on a mattress before placing a perfectly level table on top of it. If you wait for the mattress to compress after the table is already there, the legs may end up at different heights. That problem becomes extremely serious when your table is an airport. The first artificial island eventually covered about 511 hectares. A seawall was built around the reclamation area, and enormous amounts of fill material were deposited inside until the surface finally rose above Osaka Bay. From that point onward, it began looking less like an ocean construction site and more like real land. But it was not behaving like real land. Even as the surface rose upward, the seabed beneath it was moving downward. This created an unusual engineering race. Construction crews needed to add enough material to keep the island above its intended final elevation while simultaneously predicting how much of that height would eventually disappear as the clay compressed. They could not simply build the island exactly 4 meters above sea level and assume it would remain there. They had to overbuild it. Imagine filling a bathtub with a giant stack of heavy blankets and trying to predict where the top of that stack will be after the blankets have compressed for 30 years. Except each layer beneath Kansai responded differently. The shallow clay could be treated relatively effectively with sand drains, but deeper layers created a more difficult problem. Those deeper Pleistocene clay deposits extended far beneath the seabed, alternating with sand and gravel layers. Some settlement analyses considered deposits hundreds of meters below the seafloor. The weight of the new island was enormous enough to affect those deeper formations too, and unlike the upper layer, many of them could not simply be filled with millions of vertical drains. That meant long-term settlement would continue after the airport opened. This was not necessarily catastrophic. A giant island sinking evenly is much easier to deal with than different parts sinking at completely different rates. Think about lowering an entire dinner table by 1 centimeter. Nothing spills. Now lower only one leg by 1 centimeter. Suddenly, everything starts tilting. Uneven settlement was the real enemy. Runways need to remain extremely smooth. Terminal floors have to stay level. Bridges, pipes, utility tunnels, baggage systems, and roads all need to line up even while the ground beneath them moves. So, Kansai became filled with monitoring equipment. Engineers measured settlement across different parts of the island and watched how structures responded. The terminal itself incorporated systems that allowed some supports to be adjusted as the ground moved. Rather than assuming the building would never shift, parts of it were designed around the possibility that leveling corrections might eventually be necessary. That philosophy runs through the entire project. Kansai was not designed to defeat geology, it was designed to continuously compensate for it. After years of construction, the first runway finally opened in September 1994. From a passenger's perspective, everything worked. Aircraft landed. Passengers walked through the terminal. Baggage moved normally. Trains and vehicles crossed the access bridge. Japan had successfully placed a major international airport where there had once been nothing except seawater. And then the measurements kept coming. The island was settling more than early expectations had hoped. This did not mean it was suddenly falling into the ocean. Subsidence is much slower and more complicated than that. But every extra meter mattered because the entire airport existed only a limited distance above sea level. According to Kansai Airport's latest published monitoring, the first island had experienced an average total settlement of about 13.72 meters by December 2025. About 982 meters of that had already occurred before the airport even opened. That detail is important. If you simply hear that Kansai has sunk more than 13 meters, it sounds as though an airport built in 1994 has dropped 13 meters since passengers began using it. That is not what happened. Most of the settlement was deliberately allowed and expected during construction. The current rate is dramatically slower. Kansai Airports reports that settlement on the first island was down to around 5 centimeters per year as of 2025. But 5 centimeters every year is still not zero, and an airport surrounded completely by ocean cannot ignore that. Because as the island moves downward, the sea does not need to rise for flooding risk to increase. From the airport's perspective, the water is effectively getting higher. This is where the seawalls become critical. Kansai's island is surrounded by coastal defenses intended to keep waves and storm surges from flooding the runways and terminal areas. Most days, they are barely noticeable. During a powerful typhoon, they become the only thing separating a functioning international airport from Osaka Bay. And Kansai has already discovered what happens when the ocean wins. In September 2018, Typhoon Jebi struck western Japan and produced a major storm surge around the airport. Sections of Kansai were flooded, operations were disrupted, and a tanker driven by the storm collided with the bridge connecting the airport to the mainland. For a facility built specifically to operate offshore, this was one of the harshest possible reminders that sinking was not just a geotechnical problem. It was also a flood defense problem. Every centimeter of lost elevation changes the relationship between the runway and the sea. So, after major storms, coastal defenses, drainage, electrical systems, and emergency planning have all had to evolve. This is another reason the airport can never really be considered finished. Normal airports require maintenance because pavement cracks, machinery wears out, and buildings age. Kansai has all of those problems, plus the fact that the island itself is still changing. Engineers continue measuring settlement at dozens of locations. They compare which sections are moving faster than others. Sea defenses can be reinforced, structures can be adjusted, infrastructure has to tolerate gradual differences in elevation. The airport is essentially being maintained against geology and the ocean simultaneously. And yet Japan did not stop after the first island. As air traffic continued growing, Kansai needed another runway, so engineers built a second artificial island farther offshore. Construction on that phase began in 1999, and the second runway entered service in 2007. This time, the team had decades of additional data from the first island. They knew much more about the clay beneath Osaka Bay and how the ground actually behaved under an enormous reclamation load. But the second site also faced deeper water and similarly complicated geology. Again, the seabed had to be improved. Again, millions of tons of material were added. Again, settlement had to be predicted years into the future. The second island ultimately became even larger than the first at roughly 545 hectares, and it is also sinking. The difference is that the engineering predictions and construction strategy could now use everything learned from the first phase. That is one of the most interesting things about Kansai. The first island was not simply a finished airport, it became a full-scale laboratory for how extremely large artificial islands behave over decades. Measurements taken there influenced the second phase and contributed to engineering knowledge used in other reclamation projects around the world. You can now find artificial islands beneath airports, ports, industrial facilities, and entire neighborhoods in many countries. But Kansai remains one of the most extreme examples because of the depth of the water and the unusually compressible seabed beneath it. And that raises the obvious question, was building it there actually a mistake? It is easy to look at the sinking, maintenance costs, and flood risks and decide the whole idea was flawed, but that ignores the problem Kansai was designed to solve. Osaka still needed airport capacity. Building a giant new airport in an already dense urban area would have created enormous noise and land acquisition issues. Putting the airport offshore moved aircraft away from millions of residents and allowed a major international facility to operate with fewer restrictions. The engineering problems did not disappear. Japan simply traded one set of problems for another. On land, the challenge would have been people, space, and noise. At sea, the challenge became clay, settlement, waves, and storms. and engineers chose the problems they believed could be controlled. That is really the story of Kansai International Airport. It was never about somehow discovering a patch of ocean strong enough to hold an airport. The seabed was weak. Engineers knew it was weak, so they designed around that weakness. They drove more than 2 million drains into the seafloor to accelerate consolidation. They placed hundreds of millions of cubic meters of fill into Osaka Bay. They monitored settlement across the islands, built structures that could tolerate movement, reinforced defenses against the ocean, and continued adjusting the airport decades after it opened. And the process is still happening. Passengers arriving at Kansai today may never notice any of it. They see a runway, a terminal, a control tower, maybe the ocean outside the window, but beneath those ordinary airport surfaces is a thick artificial island pressing into layers of water-filled clay that are still slowly responding to weight added nearly 40 years ago. That is the part that makes Kansai so unusual. Japan did not really build an airport on the ocean. It built new land first, knowing that land would immediately begin sinking. And then it built an airport engineered to keep working anyway.